Hope you all had your lunch. So just wanted to make sure that you don't die due to hunger. It's better to sleep after lunch. Right. So thank you for such a wonderful introduction. The focus of the session today would be to basically understand the problem space, how we can solve those problems through various techniques. We'll primarily focus on the understanding the foundation, understanding of the solutions. So let me start with the agenda, how we are going to start setting the context. So statement of context is going to be the first section. We will spend some time in understanding the different aspects of problem. And I'm going to focus certainly on certain areas. I'll talk in detail later. Then we'll go a little bit deeper into the technical aspect. That's the objective of technical deep dive session. So I believe you expect some of that. I'll also try to keep it as simple as possible because I believe in keeping it simple for understanding. It's not for making life complicated. It's already so complex. Then we'll talk about certain examples. My intent here is to give you some idea of the business applications, how to actually apply in real life so that you have some takeaways, which we are going to recap here, and then eventually we'll have some time for you to ask questions. So that's the story from my side for today. And then let me start with the statement of context now. Well, to keep it, to break the ice and to keep it on a lighter note, let's start with the question here, what's the problem, which is our major thing to discuss today, like what's the problem? And let's look at the conversation that these two people are having. Well, we have a problem of plenty. Well, what is in plenty? The answer is problems. So that's the problem, right? So the problem is that we have plenty of problems. And I don't want to trivialize it, but it's an important message that I wanted to give, that there are so many things to look at. And hence we have to pick and choose what to do. And then if you look from the perspective of a head of an organization, or CEO, for example, he would be he or she would be facing such kind of challenges. Like they have a bunch of problems to solve and how to deal with all of them. And then they have to look at different departments to solve for that in collaboration. Right? So that's one small message I wanted to give. Now let me take you back to the childhood days, and it's a real story. So when I was at the age of 7, I used to visit my maternal grandma a lot, and we used to play these board games, Snake and Ladders and Ludo. Her question used to be like, you choose, you decide which board game you want to play today. And I used to give very random choice thing, like, okay, I'll probably today go with Snake and Ladder, probably today we'll go with Ludo. Few days passed, and then again she asked the same question like every day, and I said, Snakes and Ladder. And it kept on repeating, I said Snakes and Ladder all the time. So she started asking, what happened, like you don't like Ludo anymore? My answer to her was that, to be honest, I sometimes win Snakes and Ladder, sometimes lose. But Ludo, I always lose to you. So I don't want to play it anymore with you. And then she again gave me a lesson of life, that life is a lot less than a Snakes and Ladder, which is basically a game of luck. But Ludo is more strategic compared to Snakes and Ladder. So again, this is something which we have to keep in mind. As we look at things in a different way, we understand that there are a bunch of activities that we have to look at. For example, here we have to just worry about one or two tokens, like my token, my opponent's token, but here I have to look at all things together. So that's why, again, it's related to the concept of plenty of problems that we have to deal with. So she gave me this thing, like, do not miss the forest for the trees. It's a saying, but she also said in her own way, which I always keep in mind whenever I try to solve any problem for my clients. Okay, now if we look at the problem space, there are multiple ways of looking at it. Some may say that, okay, it should be based on the complexity. Some may say it should be based on the nature of the data involved, quantitative, qualitative. But the biggest thing is, or I would say the highest dimension is the purpose. Like, for whom are we solving this problem? So we may be solving it for, let's say, ourselves. And in the in the era of early humans, the problem was to hunt for food. And in our case, you can say it's a problem of upskilling ourselves. It's similar. We have to hunt for food. We have to survive. So that's a problem that we're solving for ourselves. And this is just an example. Or we may be solving the problem for others, for our friends, families, family members, relatives, etc. Then we solve problems for businesses. And I'm not saying that business problems are more complicated than others and for ourselves, but just a different set of people or set of organizations for whom we are solving the problem. Then society. Here we have to make sure that we look at a broader view, and we also try to be more inclusive and make sure that inequalities are reduced or taken away in terms of, say, gender, pay, finances, etc. And if you look at humankind, mankind, so then the problem is of a different level. And sitting in India in second half of 2023, we should not forget about space missions. So we should be very proud of that. So these are a different set of, a different level of problems that we're talking about. The payoffs may be varying. For example, for ourselves, the survival is the payoff that you have, and for mankind, it will have evolution. But yeah, eventually, we have to focus on the area that we work on. So I will probably focus primarily on businesses today. Again, it's like looking at the full picture before getting deeper into something. Now, if you look at businesses, businesses need to make decisions, and these decisions are driven by their objectives. And the objectives may vary. The first important objective that everyone may think of is profitability. But that's not the only thing that we need to worry about. There are 100 other things. So it may vary from, say, customer satisfaction, retention, to employee satisfaction. So all those objectives, again, are there with the person who's running the business. If we go line by line, if you just look at the first one, profitability, and these are, again, examples. Let's take an example of an insurance company who needs to decide, whether we should, what premium we should charge to a customer for an insurance policy. Well, it becomes a problem of estimating a value, estimating the premium amount, right? Continuous variable that you are estimating. If it's a objective of growth and expansion, and if we take example of an entertainment industry that has certain spend amount in budget, but doesn't know where to allocate that budget. And it's a very popular saying that I know 50% of my marketing spend is going to be useless, but I don't know which 50%. So, well, for that, you have to make sure that the right techniques are applied, like media mix modeling, marketing mix modeling, as we say, to optimize the ROI from each marketing channel, and becomes a problem of optimization. If you look at customer satisfaction and retention, and let's take an example of hospitality industry. Probably the restaurant owner may be worried about whether this customer is going to be coming back to my restaurant or not. And then you solve the problem of classification. It's a binary classification, it could be multi-class. Then let's take an example of innovation and differentiation. Very common thing for e-commerce websites. They need to recommend whether a customer who bought this also bought this and not. So that's a recommendation engine kind of a problem. But then it's a different from estimating a value or optimizing allocations, right? So it's a problem of discovering the association. If you look at operational excellence, let's take an example of a bank that needs to allocate the customer care executives in such a way that they are fully utilized. For that, it becomes a problem of call volume forecasting. So it's a different problem altogether, where you are forecasting a time series. Then for employee satisfaction, let's take an example of education institutes. So they need to decide which faculty member they need to retain, and they need to incentivize them. So first of all, they would do the segmentation exercise. It's a problem of clustering. So this is just to give you an example like how these objectives get translated into decision points and then eventually into a statistical or analytical problem. Now, there are so many industries. We just took example of few. I just wanted to highlight. You may all be from different industry. Not everything may be relevant to you. We are focusing on banking today, given a lot of my time has gone into it, and I would do justice to this better than any other industry. So now let me show you this space where we are dividing the entire spectrum into the analytics spectrum versus the business objectives. Now, business objectives, as we discussed, are of many types. So we can categorize them into three broad categories: automation, optimization, and innovation. Well, automation is primarily to make sure that there is speed to market and standardization, so that everyone who is, for example, working on something is producing the standardized output for the business to consume. So optimization is primarily for more kind of trade-off decisions. Let's say improving a model algorithm, so better accuracy, right? Or to improve the profitability by taking some decisions on, say, should I focus on, say, declining a fraudulent transaction, or should I focus on customer experience? It's kind of an optimization problem. Then if you look at innovation, this is something which is very important for all businesses, and they need to spend some energy and time on this. It's for transforming the entire business model. So here are a few examples. I'll not go through all of them, just to give you some idea about how they look like. And this is for banking industry, and primarily some examples and not the exhaustive list. So let's say you are working on tracking the performance of some statistical models. So the best way to do it is to automate it, right? So there's no intelligence required as such to improve the process. I mean, there are certain algorithms which are already calculating metrics, and you know how to interpret them. But you have volume. So in this case, you would want to automate it. It's better to go with a plug-and-play API rather than creating some new algorithm around it. But let's take an example of diagnostic versus innovation. So you have a problem of churn. Churn means customers at writing. Now, one traditional way of looking at things is to look at the data and build a model of churn with a binary classification, churn, no churn. However, you can also look at the call transcripts between the customer and the banking agent. If you're able to apply some topic modeling there, then it becomes a lot more powerful to understand the root cause of issue, why people are complaining in the first place. If I can address that issue, then it will not lead to that kind of an escalation in customer's mind that he will or she will write eventually. So these are some examples. One important example here is cognitive. So cognitive is a relatively new field, I would say, compared to the others. So descriptive, diagnostic, predictive, prescriptive, and cognitive, they are like in the increasing order of their value chain. So for descriptive means like all those analysis where you try to understand like what happened. Then you go to diagnostic where you say why it happened. And okay, can I do something about it and all that, right? So you have to predict for future. Now, if you have predictions, then you need to take actions. So you need some prescriptions. And finally, you have to build or implement the solution in such a way that, you act like humans when interacting with your customers, because your customers are also humans. So that's the reason cognitive analytics has picked up a lot of traction now. And if you take an example of innovation, contextual decisioning is something which, it's something which is very much in trend. And it's basically about having that kind of solution provided to the customer where you understand the context through unstructured data. And large language models are very, very critical and I would say significant here. And it's coming under the field of generative AI. But I'll go deeper into it now, and we'll talk about how things happen there. But before that, like whenever I go to conferences, and in fact, I have also seen many conferences where people talk about data velocity, right? And some smart person from the audience pops up and says, no, whatever you're showing on the screen is actually invalid because as per some latest report, numbers have changed. So I don't want to take that risk. So I'm just sharing my experience. And 2 decades ago, I was in college, I was working with a friend on some project on statistics, and were supposed to submit it. And we used to use floppy only, and there was only 100 kbs or 100, 200 kb of data that we used to save. And we were sharing that information. There was hardly any phone, and whatever we had was a very QWERTY phone, right, where you had no fancy feature of smartphones. But 2 weeks back, when I met the same person again, we were discussing which iPhone should we buy now? Should we go with 15 Pro or 15 normal? And then we started taking out our phones from our pockets and saw that both of us have 2 phones, first of all, and then also they are already filled in terms of their space. And we were considering cloud space as also as a consideration. So that's the view I have in mind. That I don't want to go into numbers, but this has definitely happened in my real life, so I know it has happened in everyone's real life here. And you can understand the pace at which data has grown. If you look at the variety of data, that's another aspect why AI has become so popular. Because of the variety of data now we need to deal with. It's not only tabular, so many audio, video, sensor data is there, weblog, text is already there. So all these data types make the problem a lot more complex. Now it is increasing the number of problems, also the level of problems. Now let's move to one of the most popular Venn diagrams for AI. So you all understand AI. It's a field of computer science, to build computer systems that can do tasks which require human intelligence. Right? One of the subset is machine learning. Basically, it's about developing algorithms for enabling machines to learn from data. Now, many times people ask, okay, this is machine learning, but what if we do not talk about the other things? So I just wanted to highlight for our basic understanding that there are algorithms that are not machine learning, but still part of AI. And rule-based system, genetic algorithms are examples of them. So rule-based algorithm, a very good example could be a spell checker, or even when you need to play chess, when you play with the computer. Right? So it's all programmed. It is not machine learning. Within machine learning, we have deep learning. Now, deep learning is, as you know, it's all about building neural networks with multiple layers. Again, the question comes what are those algorithms that are not deep learning but machine learning? And there are so many problems that can still be solved without being so complicated in terms of our solution. So we focus on these kind of examples as well, traditional generalized linear model. In fact, I got multiple promotions by building GLMs in my past life. So decision tree, clustering, all the kind of ensemble trees that we have, GBM, right, XGBoost, all are part of this bucket. They are not deep learning. Still, people ask, there are so many trees that we build, there are so many levels. We can go deeper and it can become a deep learning thing. Yes, in terms of complication, yes, but the way it is technically defined, it's not deep learning. Because it's, again, a simpler algorithm than where we basically combining the weak learners together to find the predictions. If we now look at NLP foundation model, this is something which has been popularized a lot by Stanford University. In recent, I would say 5-6 years, this thing has picked up. So these are those large-scale pre-trained deep learning neural network models that have the capability of transfer learning. Basically, the idea here is to leverage the existing models and build something on top of it by customization. So if you have built any complicated, say, gradient boosting machine tree, it is still a technique. It doesn't give you the data. So you don't have a model that you can just apply. You have a technique which you can call and you provide your data as input, and it gives you a tree or a bunch of trees. So, but this is different. Here, the model itself has been built. Multiple models have been built, and they can be leveraged as is, or you can also improve them by fine-tuning and prompt engineering. The thing that has picked up a lot of traction, generative AI, many people are talking about it, so we should definitely look at it. Focusing on generating new data. So the difference between NLP and generative AI should also be made very clear. So let's look at those things which are falling under NLP foundation model but not under generative AI. Right? Word embedding model. So this has been done by Thomas Mikolov in 2013. He was in Google and he came up with the word-to-vec model. Right? And he's pioneered the research in this area. It has activated multiple other models. Stanford University also came up with their model. So these models are extremely, extremely important to understand how natural language processing works. Then there are other activities also, like named entity recognition, and there are other algorithms. But now let's look at those which are part of generative AI. So these are like data generation algorithms. So it would be for tabular data, image, video, any kind of data, right? And then there are things that are outside these two circles, but are still part of deep learning, right? So these are the object detection models. Like face detection, for example, is a very good application. It's part of deep learning. It's not generating any new data. Deep reinforcement learning is important for autonomous cars. So it's part of deep learning, not part of generative AI. Now, the overlap between these two is text generation, and where the large language models come into play. The part here is that even these things are advancing towards multimodal LLMs. So multimodal means that you can ingest not just text, but also images, videos, anything, and then transform it. So that's a concept I wanted to share with you. Let's move on. Well, intuition behind new data generation, again, it's going to be a bit foundational, but I would want to spend some time on it so that everyone tries to get the concept here. So we will estimate distribution by counting. And don't mind these notations, we're statisticians, we love talking this way, but I'll simplify. So for example, if you're doing any experiment and we have certain observations, and we need to replicate the similar kind of a data, but generating new data of similar distribution, that's what we are trying to do here. So x1 to xn is a sample of observations, right? And we are trying to estimate q hat here, which is following the distribution q. And these x1 to xn are taking value v1 to vk, right? So they are following a finite set of values. And I'll explain it through an example. So let's say we roll a die 10 times, right? So this is what we are going to get. 10 times we will get some values between 1 to 6, because this is a fair die which has 6 faces, numbers written on them. And that's why this v1 to vk are actually 1, 2, 3, 4, 5, 6. So k is 6, n is 10. Now, if we just draw the histogram, so we would just look at the frequency of 1 to 6 here. We'll have the probability mass function of q, which is straightforward, just plotting it in a bar chart. Now, what we are doing here is we are calculating the probability of v, and eventually to do the CDF, which is cumulative distribution function, right? So what's the probability of occurrence of 1? So 1 is occurring 2 times out of 10 times. So that's why the probability is 20%. It's that simple. And as we are moving from 1 to 2, we are just adding up these probabilities. So CDF is a cumulative distribution function, which we are plotting here. Now, assuming that this function is invertible, right? What was our objective? Our objective was to generate some values like these in column Q, ranging between 1 to 6, right? So now we can just take a sample from 0 to 1 and see where it lies, and we can get the x's. So what we have done, or what we have achieved by transforming PMF into CDF, in case of PMF, our y-axis had no bound. Actually, the bound was n. So because there are n observations here, the bound was n, 0 to 10, right? But in case of CDF, we have converted into a nice function where we have now y-axis ranging between 0 to 1 only. Now, if you just write a function of generating random numbers from 0 to 1, you should be able to generate q hat, right? And it's not going to be that simple that you'll get the answer in the first go. It's an iterative exercise. You will keep generating numbers and you'll keep getting q hat. Right? So in the cumulative distribution function, we are just randomly selecting value of y and the corresponding X values getting generated. That's a concept of generation of numbers. Okay? And it's a very basic concept. There are other things also. Obviously, the deep learning neural networks are there, but I'm just trying to make you understand how it works as a concept. Now, what happens if we roll the dice sufficiently large number of times, not just 10 times, right? So just to make my calculation simple, let's say 6 million times. So now each of these phases, 1 to 6, will have equal frequency because it's a sufficiently large number of times that we're doing this experiment. And everything will become very simplified, actually. So now my cumulative distribution function is going to be a straight line. And I don't need to actually generate any random value. I mean, I know that how it is going to look like, because it's just a problem of appending, say, one time to 1 million time, and so on. And if you keep on doing that, it just becomes a problem of sorting random values. However, life is not that simple that we just roll a fair die and we just don't just deal with numbers, we deal with text as well. So let's take an example of text. Let's read these 3 sentences. I love humans, I love machines, I love both humans and machines. So these are 3 sentences, and coincidentally, they are also translating into that finite vector of v1 to vk, where I have k values, 6 values. Now, if we now reproduce that probability mass function and the cumulative distribution function that we just talked about, we may get an output something like that, which makes absolutely no sense because, I mean, this is English, this is text, not just numbers. But if we ask, what's the sentiment, then we are getting an answer which makes a lot more sense. Well, I'm talking about I love humans, I love machines, I love both. So it is giving me a sentiment that's very positive. But what if I say reduce the text but retain the meaning? Then it is going to remove the redundant information and only focus on the meaning of it. And that's why it has just retained the 3rd sentence here. If I say translate into some other language, it's able to do that. If I say rephrase the given information, now, I mean, it becomes even more interesting. The words that were not even provided as input are getting popped up here. I see cherish, fusion, adore, equally. So all those words are again picked up by the algorithm itself because it has seen the broader corpus of data. What if I say summarize the given information? Well, it has taken it to the next level where it has understood the thing like a human and has also told me that it's not just equally, it's a balanced appreciation for both human and machines, right? So now it's of a different level. The task of complexity increases from low to high as we move from 1 to 6 here. Now let's look at the things that are helping to solve this problem. So natural language processing is heavily used here. So I'm just giving you a schema of things here. So start with the entire box of NLP. Then we have the natural language understanding as part of it. Right? So the way it is different is it's not just about processing the information, but also understanding like English we just saw. Then natural language generation is another concept which is part of NLP, but then it's not subset of NLU. It's something which is again residing in under NLP as a separate entity, and there is an overlap between both of them. So if you look at examples like syntactical processing of information, part of speech tagging, these are all coming under things which are outside NLU and NLG. But if you look at NLU, it's more semantic understanding of the things, right? Like generation of the name and entity from sentences. If you look at natural language generation, that is more like translation of one language from one language to other language, or text summarization. And the overlap will have some things like dialogue, where we have questions and answers through chatbot or virtual assistant. Then there's a layer that runs across all things. That's a text pre-processing layer, where you have to make sure all these things happen. Like we do the tokenization, we do the lower casing, we do the stemming, lemmatization. All these things are done so that it's understood to the machine, like what we are giving as input. Right? So it's just not a sequence of numbers. it's a sentence with a meaning, it's a text with a meaning, which is getting coded into numbers by computer itself using word embedding kind of models. Okay, now let's look at transformers. We looked at the NLG part, but in NLG, if you remember, we talked about those two circles as well, where we had the NLP foundation model and generative AI. The overlap of two was LLM. So NLG is very similar to that because you are generating new data, so it's part of generative AI. At the same time, it's part of NLP, so it falls under that intersection. So this transformer is one of the ways of generating text or even actually images. So let's look at encoder-only models. So these models are relatively simpler, but they include only one component, which is encoder. And what it does, it processes the inputs into a latent representation of data, which is of higher dimension. Which essentially means that when you're providing inputs as a series of data points, it is translating into a higher dimensional output, which is like feature extraction. So objective here is extracting feature, not doing everything. So if your objective is to extract information, extract features, information retrieval, then it's going to be a good model to use. Then encoder-decoder model, it's like a teamwork. So there are two components, encoder and decoder. So encoder converts the input into some encoded text, which is utilized by the decoder to transform into, again, a lower dimension, which was similar to the input dimension. Right? So here translation is a very good example. Like when you are providing some text, it is giving you the same text in the same dimension, but in a different language. It's doing it in sequence. So it's also called sequence-to-sequence modeling. The decoder-only models, which are very popular these days, all GPT models are decoder models. So they work on the auto-regressive methodology, right? So basically, they understand from their own errors. They just need some information to predict for future. So if you look at it from storytelling point of view, right? So let's say you need to tell a story to someone or write a new story, then encoder-only models are only acting as detectives. They're just collecting the clues from here and there, right? But the encoder-decoder models are like a dual combination of two storytellers. Like one is initiating the story, other is ending it. And the decoder-only models are those where it's a one-man army. The same person is writing the entire story. That's how we can understand it in a simple way. Now, story time from my side. So basically what happened is, we went in this long weekend of 15th August, we went to Ranchi to meet my in-laws, and we came back. So, the lady on the left-hand side is my mom, and the boy on the right-hand side is my son. She asked a very basic question, where did you go? And he answered, restaurant. She asked another thing, like, what did you like? And his answer was fish. Everything was going fine until this point. But we are vegetarians, and my in-laws aren't. So she was about to freak out, and we had to intervene. Right? So that's where my nephew and we had to intervene. And then when she said, okay, we said, just replay this game. What did you like? So we just said, she's asking, what did you do? And he memorized that aquarium that he saw in the Kaveri restaurant in Ranchi. Right? So he said, okay, I saw fish. And then we said, what did you eat? And then he said, I had ice cream. So basically, this is the part I wanted to highlight, that this person is a consumer, this guy is an AI model, we are humans, right? So if you just, from analogy standpoint, so we are data science team, or business teams, and this guy is the person sitting, is the regulator. So I just wanted to keep him happy, so that's why I have taken his happy picture. So these regulators are very important, and so if we need to make sure that everything is rightly governed. So as humans, if we are part of data science and business teams, we need to make sure that the solution is correctly implemented. So we are responsible for prompt engineering, fine-tuning, etc. But the regulator is also human. So as human, if we are a regulator, then we need to make sure that other people are doing their job properly. Right? So human in the loop for the consumer and for governance. So both the parties are important. Now, how to leverage large language models? So assume you have a foundation large language model, any model. which you have access to. So you won't have access to the GPT-4 because they have not made it open source as of now, but you have access to, say, Llama 2, right? So let's say you have that kind of a model, then you would do probably prompt engineering, the thing that I just did to my son, right? I just gave him a simpler question so that he understood and gave the right answer. So optimizing the input prompts and all that. So this is basically part of prompt engineering. In context learning is one level higher, where basically we are giving some example to the model to understand. We are telling that, okay, I mean, giving a very simple example. It's not good at mathematics, but if I am telling 2 plus 2 is 4, then it will understand 20 plus 20 is 40 and not 4,000. So those kind of context setting is required even in textual inputs. This context setting actually plays wonders. So if we just say that if I ask this, this is the answer. This is a kind of in-context learning that I'm providing to the model to provide appropriate responses to me. Then fine-tuning, it's a broader concept where we have to actually go ahead and modify the model. And I have, I mean, these are different players working on this, business users, data engineer, and data scientists. It's like a teamwork, by the way. These are key players only. So everyone is involved in every exercise, but these are the primary players in each of these exercises. If you look at fine-tuning now, so here we have to make sure that we define the business goal properly. Unless and until we have the context setting in advance, we will not be able to do justice. Then we need to collect the data carefully. I mean, data preparation is going to be extremely important, because if we are fine-tuning, we believe that the existing model is not working anymore. So we have to make sure the data we are providing to the model as an additional exercise to get fine-tuned on should be good. Then we have to choose the LLM very wisely, right? So these LLMs are very, I mean, different in their nature. So let's say you are doing code generation. You would not want a model that does text summarization well. So you would probably go with the model which does code summarization better. So depending on what your problem statement is, you're going to choose your large language model. And it also depends whether you are on cloud or not on cloud. So those activities are also important to be as consideration. Then you need to build your domain-specific vocabulary, because this is a part, if you are going to provide that domain-specific thing. So for example, you are launching a new credit card, and you put a very weird name to it. Now that name would have its own meaning. So it's important, unless and until you provide that name which you have provided to your credit card is part of your vocabulary, it will not understand what you're talking about. So you have to make it very domain-specific here. You have to also design the task prompts specifically for task. Then optimizing hyperparameter. This part is fairly easy, as in there are a lot of functions that can help you do it. But it's an important activity to be considered. You have to optimize the hyperparameters for fine-tuning. You need to do regularization technique, because you don't want your model to be overfitting on certain data. Then you are going to evaluate the model performance, and it's going to be an iterative loop, right? So, I mean, there are many techniques of doing it. Some people just do it basis their own intuition. Some apply that reinforcement learning with human feedback. So those kind of techniques are available for providing this feedback loop. Then finally, you select your model. And before going live, again, you have to keep the regulators happy. So you have to make sure that compliance checks are done. So of course, while building the model, you have to have the compliance guideline. But eventually, before implementing, again, you have to run all checks so that you do not end up saying some wrong things to your customers, because it's an AI who's talking and not you. So with that, now let's look at some examples. I'm not selling EXL here. I'm just giving you some certain use cases that we have worked on. But irrespective of that, you have to make sure you understand this concept of employee-facing, rep-assistant, customer-facing. So these are the kind of use cases that are going to be very crucial for businesses. So there are certain use cases which have less exposure to AI. So employee-facing or middle office operations rep assistants, they are having lesser risk compared to the customer-facing solutions. So our primary focus now, at least in banking, on our first two categories. And there are multiple examples. For employee-facing, you may do code generation, right? So people do a lot of coding in the organization. If you have certain ways of doing it through large language models, why not? So that's one. In case of rep assistance, you can have a call going on between a customer and an agent, and the bot can give some recommendation like how to handle that call more efficiently and effectively. So that will be a job of call center agent assist. So for today, we'll focus on SAR investigation. I'm just giving you one example. SAR is basically suspicious activity reporting. Banks are supposed to do that as per the regulations. So I'm giving you some snippets of a news. Here we have $390 million fine imposed on a bank in 2021 because it failed to file thousands of suspicious activity reports. So it's a pretty huge amount. I mean, it's going to charge it to their customer in some way or the other later on. So it's important the banks don't face these kind of things to begin with. Again, FinCEN announces another penalty, and that is of $140 million to another bank, and that was in 2022. And these are like just examples. If you go to their website and search for that, you will find a bunch of such news items. And again, the issue was that they failed to implement their anti-money laundering program properly. So banks face heavy penalties for missing out on these regulations. Right? So now, if you just look at what this particular solution is going to look at or do for the bank, it's going to make sure that all kind of evidences that an agent is supposed to verify before calling that activity suspicious, those evidences are compatible with the solution. Right? It should not be like, okay, it's a evidence in picture format, it's a screenshot, it's an audio, it's a video, and I cannot take it. So the solution has to be more flexible, and you have to obviously look at the kind of evidences you typically deal with. So in case of suspicious activity reporting, there are 3 stages to begin with. First of all, the stage of alert. So where some activity, I mean, you track just by looking at certain rules and the data, and some alert gets raised. Now then you need to investigate that alert and see whether it's actually suspicious activity or not. And finally, once you decide whether it's a suspicious activity or not, you go with filing that activity. I mean, if it's a positive case, suspicious activity case, you're going to go ahead and file that report within 30 days. So that's the process. And what we are doing is the middle layer, which is the investigation part. Right? So SAR investigation is what we are trying to achieve through here. And we are going to generate some insights and do some case summarization. So it's just certain screenshots that I have taken from the solution. So what we are doing here is we are selecting the case type and case ID. The case type could be, say, anti-money laundering. It could be disputed fraud transaction. It could be insider trading. Those kind of things are there. Once you select the case ID, case type, then this information gets fetched from the backend in the bank system. And you also have an option of choosing the LLM. Right? So I'm just trying to give you an understanding when you think of such kind of solutions, what things you need to keep in mind. Right? So if you have flexibility of choosing the large language model, whether it should be open source or closed source, that will be great. If you've already decided on it, then you'll probably focus on the one that you have decided on. Then here we see example. When you fetch evidence, you have multimodal examples. You can insert images or text. Then here the bank agent would just click on generate insights and start getting the answers. But he or she would also have access to certain questions that he needs to ask the document. Right? And he can also ask his own questions. So these are some sample questions that are based on a typical assessment of such kind of a case type. When you generate the answers, you get instant answers, but at the same time, you also get some recommendation. Now, these recommendations are very important because we did not ask for this recommendation. Like, as a user, did not ask for this recommendation. But you're getting it because, I mean, that's the power of this large language model. They understand the context and are able to provide a lot more information than you need. Here, it is highlighting clearly that why it is a suspicious activity. It's a high-value transaction. It's an online transaction. At the same time, the suspect has been identified whose name and address are not matching with the customer name and address. Right? So there are clear reasons of why it is a suspicious activity. Once you have this understanding, so think of it as a bank agent. Now you don't have to go through hundreds of pages, spend your entire weekend on that. You just need to use some solution like this, and you'll get a good summary of what is going on at the back end. And then should be able to also summarize all this information in a nice format. It's a natural language. You can also download the reports. And finally, when you have to make a decision, again, the solution is going to recommend whether SAR filing is required or not. And it's going to go back to that Bank Secrecy Act in this case and see if all those conditions are being met or not to call it SAR filing eligible case. Once this is done, then again the user would have that decision-making power of going ahead with AI's recommendation or override it or refer it to someone else. And that's where we call human is back in the loop. So that is about this application I just wanted to highlight as an example. Now, just recapping the takeaways. We talked about multiple things today. We looked at the things from a broader perspective. We should not be focusing only one thing. It should be a full picture. There are multiple problems. Then we also mentioned about the Venn diagram of AI, ML, DL, right? So hopefully that would have given you some insights. We also looked at the intuition behind data generation. Then we looked at the NLP, NLG, NLU relationship. We talked about transformers a bit. And finally, we looked at an application. And all these things are all okay. But I just want to say that it's not about human versus machine, right? So that one thing we also need to keep in mind. It's not about human versus machine. And if we ask this question to machine itself, it says it's not about human versus machine, but about human and machine working together, right? So now with this, and if I say just let me go one step ahead and add it further and complete it for the machine, well, it's not a battle between human and machine, but a battle between problem and intelligence. Well, the answer that we get is yes, you're welcome. That's a great completion of the phase. So that's just a demo of the ROI of this collaboration between human and machine. If we use it properly, responsibly, we are going to get the right outcomes. So let me conclude here. And it's up to your time to ask questions. If you don't have questions, I'll give it back to you. Okay.
Check.
Thank you.
Check. I think there are questions. So.
I have a two-part question. I know we talked about data velocity, but model velocity is also going to be an issue in some time, right? So we are constantly innovating. There are constant models that's coming out on a day-to-day basis. So the first question is around model choosing. For the solution that I fixated or for the POC that I want to do, how do you go about choosing the model itself?
So if you decide on the objective first, let's say you need to summarize the text, then probably you'll go with Llama 2 example. If you are going with code generation, probably you'll go with star coder. So those kind of, first of all, objectives need to be defined. There are multiple considerations. First is the objective. Second is your cost, right? Because though you are going to reduce the cost by implementing it, but AI is not for free. So there's going to be huge cost in infrastructure. So you would need to pick and choose between what you have. Let's say you're already on cloud. Then you have a lot of cloud solutions available which are integrated with the LLM models. If you don't have cloud, then you have to go with that route of using the open source, customize it. So the infrastructure problem is also there. The objective problem is also there. And then you also need to make sure that it's something which is useful for your customer. You are able to generate the ROI. So technically, all looks good. But eventually, when you're going to implement, you saw the kind of impact this suspicious activity thing is there. $390 million fine, $140 million fine. If the fine is only $10, $20, $100, $1,000, probably you will not worry much, right? So it also depends on the ROI part.
Got it. The second question is, once we choose a model, and let's say it's working really well, but given that the model velocity, there is a better model which can do the job much better. So we run into a problem of model change management. Any recommendation on any pointers or how you would tackle that?
So yes. So when these organizations are updating their model, they are not changing their architecture fundamentally. For example, there was a model by Google T5, and they have come up with Flan T5. Right? Flan T5 is also encoder decoder. It has not moved to decoder only, but GPT is in decoder version only, right? So first of all, you would see that if you are going to use the same latest version of the same kind of series, it would have backward integration.